Now, forgive me, but I squeezed in this video quite randomly because I realized that I haven't told you about one important convention, the squiggly line and the R. They are used in a very similar way. For instance, they are both used to represent functional groups. Take, for example, an aldehyde group. You know that it is CHO, but on a diagram we cannot draw it like that because carbon has 4 bonds. So we write R and treat R as a variable. It can be anything. Alternatively, we can draw a squiggly line. When using the squiggly line, we emphasize that this CHO is a fragment of a molecule that we're interested in, and we leave out the rest. As a consequence, the squiggly line is more often used in biochemistry, where researchers deal with very large systems. For instance, here we see an active site of an enzyme. We are mostly interested in the active site because it is the region of an enzyme where substrate molecules bind and undergo a chemical reaction. We draw the squiggly line indicating that the structure of an enzyme extends further, but we are not interested in it and we just leave it out. Notice that on the diagram with CHO group, we see a bond and the squiggly line perpendicular to that bond. The squiggly line marks the cut. Whereas in the case of an enzyme, we just see the squiggly line as a bond, meaning that is the last bond that has been shown. To be frank, I don't know whether the latter convention is 100% correct, but I've taken it from my biochem notes. For me, the most important thing is that you know what it means. And the truth is that some lecturers do agonize over conventions and nomenclature, and some don't. And also, it might be the case that biochemists and biologists have slightly different conventions to chemists. I'm not sure. One more thing about the squiggly lines. Don't confuse them with these lines. Notice that this bond looks different. It is less wavy. Such bonds are often used in stereochemistry and means that the arrangement of atoms at this stereogenic center doesn't matter. I'll be talking about stereochemistry in the very next video, so I will not expand on this here. R is more often used when researchers investigate some system and vary a certain part of it, which they mark as R. For instance, in this paper, researchers investigate the origin of the steric effect. To do that, they investigate a series of acid-catalyzed ester hydrolysis. Here we see a protonated ester with R group. Various R groups are below labeled and numbered. This makes it very easy to refer to different esters in the text, and authors don't need to use the systematic names, just numbers. What is steric effect, you ask? Well, one contribution to steric effect is steric hindrance. What is steric hindrance? Compare number 1 and number 8. The number 8 is more branched out, so it will be more difficult for water molecule to squeeze past to that carbon and to do the hydrolysis, especially that the CO bond is rotating like a windmill and also very quickly. We'll talk about it later as well. At the end of this video, I would like to apologize for a certain carelessness in my last video. I used solid lines to denote some lone pairs, and although this practice is quite common, UPAC do not accept it. UPAC is not an evil, they do an extremely important job of standardizing nomenclature and terminology. Actually, it might be very beneficial for you to skim the entire graphical representation standards, just to see what other common conventions are not acceptable. However, I treat these videos not like a research paper, but like my notebook, in a bit casual way. So I cannot promise that I will not be drawing lone pairs as solid lines again, because it is much quicker and also out of sheer habit. So please forgive me and see you in the next video.